Hello there and welcome back. We continue with the parts D and E of this problem where we are asked to find the probabilities. So let's read the problem. It says the wingspan of the butterfly in town A are normally distributed with a mean of 14.1 and a standard deviation of 2.1. Now, when they tell us it's normally distributed, we can immediately refer this to normal standard distribution curve, which is giving us the probabilities under the curve in standard tables. So we are referring to Z tables. Now you can find Z tables in the back of your textbook, or you can go to this website z-table.com and you can find Z tables there, or you can Google ztable.pdf online, and you can go to a reputable edu website and to find the Z tables. Okay, here, so what they're asking us now is find the probability that the randomly selected butterfly in town A has a wingspan between 16 and 18. So if we refer to a normal standard distribution, we're being told that the town A butterflies have the wingspan with a mean of 14.1, and standard deviation of 2.1. This comes from here. Now what we're going to do is we're going to convert this 16 centimeter to 18 centimeter to Z scores. Now when we convert them to Z scores, that will basically tell us what are the probabilities under the curve for the Z scores of 16 to 18 centimeter. So we have to find Z score for 16. Z score for 16, it will be, let's use the formula first, x minus mean divided by standard deviation. My x is 16 given to me and mean is 14.1 divided by 2.1. So my Z score for this one, it works out to, from the calculator, 0.9048. Okay, so we are talking about Z score of 0.9048. Now I have written this thing on this side, so what it actually means is my mean, which is 0 here, I'm writing 0 here, is the mean under the standard normal curve, correct? So 0.94 is on the right hand side. Now what about the Z score for 18? Using the same formula, 18 minus 14.1 by 2.1, that gives me 1.857 from the calculator. This is 1.857. So if in case I want the butterfly wings to be between 16 and 18, then I need the area under this curve, which gives me the probabilities for the butterfly wing to be under this, right? So we refer to the Z score table and find the probabilities. Now we refer to a Z score which looks like this, Z score table which looks like this. Now we want for 0.9048, so we are going to refer to that as 0.91 since we have two decimal accuracies. So we will say 0.91. 0.91, the area on this side, this area is 0.8186, and the other reading was 1.86. so we have 1.8 and 6. 1.86, my reading is 0.9686. so my area is 0.9686. take away 0.8186, correct? So let's go back and we write down the area. My area here, the probability is 0.8186 from here, and for the 18 centimeter I have 9686. So I'm taking 9686, and that is 0.9686. Now I have to find the difference of these two to be able to find the area, because what I have is over here up to here is 0.9686, this whole area from negative infinity to here is 0.9686, and over here is 0.8186. So if this area up to here is 0.8616, if I subtract 0.9686 and take away 0.8186, I will get the required area, correct? So the required probability, right, the probability of the butterfly wing being between 16 and 18 is probability is between 16 to 18 centimeter wingspan is 0.9686 minus 0.8186. That gives me 0.1511. So the probability is 0.1511 or 15.11%. Okay. Now they asked us for 4 decimal places, so that is 0.511, 4 decimal places. Okay. All right, let's address part E. This was part D. Let's address part E. In part E, they're telling us that the Lorentz bird wing butterfly is considered to be very small if the wingspan is in the smallest 5% of all the butterflies in town A. So what they're telling us is, if in case I take the standard normal curve, and if I say this lowest 5% is the probability, because this is the area, right? Now for that 5% I need to find the z-score for this, and that z-score I will convert that to my sample that is given to me. So I will find the z-score for 5%. So I have to refer to the table which gives me the area. Now I want this area to be 0.05. So for 0.05 I have an area of 0.495 or 0.505. I could take either or. I'm selecting 0.495, and my reading for that is minus 1.65. Minus 1.65. That means my z-score is minus 1.615, and it makes sense. It is negative because it is on the left hand side of my mean, correct? Because this side I have z plus and I have z minus on this side. Okay, so my z-score is minus, okay, let me write the formula. Z is equal to x minus mean divided by standard deviation. My z is minus 1.615, and I need to find the actual reading, the butterfly wingspan in town A, that is x minus mean. My mean is 14.1, correct? 14.1 divided by 2.1. If I've solved this one, x is equal to 2.1 into minus 1.615 plus 14.1. From the calculator, my x works out to approximately 10.656. Now what they're asking us is find the butterfly wingspan correct to 1 decimal place. Now 1 decimal place will be 10.7 centimeters, 1 decimal place. Okay, I hope this is clear. Thank you so much for watching, and tune in and subscribe for more videos to follow, and thanks for watching.